In this video, we are going to look at a percent yield problem, which also includes theoretical yield calculations. Here is our question. If 2 grams of iron 3 chloride are reacted with 2 grams of sodium hydroxide to produce 1.10 grams of iron 3 hydroxide and some additional sodium chloride, what is the percent yield of iron 3 hydroxide? You can tell that this is already going to be a lot more complicated because we do not have a balanced chemical equation given to us. We don't have a lot of information. So what I want you to do is first focus on balancing the reaction. So first write out what is the chemical equation, then balance it, and then determine the molecular weight of all reactants and products in this chemical equation. Before you check your answers, please do stop your video and work out these equations. I'm going to want to see your work that demonstrates that you know how to do all of this. Alright, so here we have our final answer. We've got 1 iron 3 chloride plus 3 sodium hydroxides yields 1 iron 3 hydroxide plus 3 sodium chlorides, and the molecular weights are shown. So stop your video, check your work, and figure out where any mistakes were made. Now that you have done all that work to get you ready to do the problem, let's get started. So this is a percent yield problem that is actually also a theoretical yield problem because you're given the amounts of your 2 reactants and you're asked to figure out what the percent yield is based upon how much of your product you created. Now once again, I could have asked you for sodium hydroxide. It didn't matter. Just in this problem, we were asked for our iron 3 hydroxide. So if that's what we are given, we know our amounts here, we know how much we created, so our experimental yield, we just don't know our theoretical yield. But luckily we know chemistry, so we know that if we have the amounts of our starting materials, we can compare and figure out which of these 2 is our excess reagent, which one's our limiting reagent, and predict our theoretical yield. So let's do that right now. So if we start out with 2.00 grams of iron 3 chloride, how do we go from iron 3 chloride to iron hydroxide? So remember, this is just a bunch of molar conversions. So iron chloride, we want to end up with moles of iron 3 chloride, and we got grams of iron 3 chloride. So hopefully you notice that this is simply the molar mass. So in 1 mole, we have 162.2 grams. So that is our molar mass, grams per mole. Now we need to go from moles of iron 3 chloride to moles of iron 3 hydroxide. So to do that, we used our coefficients and our balanced chemical equation. So we have 1 mole of iron 3 chloride to 1 mole of iron 3 hydroxide. And then finally, we need to convert from 1 mole of iron 3 hydroxide to what we're trying to figure out, which is grams of iron 3 hydroxide. So to do that, that once again is your molecular weight. So our molecular weight is 106.87 grams per mole, which gives us a final value of 1.32 grams of iron 3 hydroxide. So that is how much we would theoretically yield if this is our limiting reagent. But we don't know at this point if it's limiting or in excess. And so we need to also calculate sodium hydroxide to iron 3 hydroxide. And so when we're doing that, let's do that next. And I forgot my 3 on my iron 3 hydroxide. So now let's do the same thing, but convert from 2 grams of sodium hydroxide. So the first conversion factor, remember, once again, is our molar mass. So we have 1 mole of sodium hydroxide is equal to 39.997 grams of sodium hydroxide. And now we need to use the coefficients in our balanced chemical equation to go from moles of sodium hydroxide to moles of iron 3 hydroxide. And then next we convert from moles to grams. So it's the same conversion factor we did up here, 106.87 grams of iron 3 hydroxide and 1 mole of iron 3 hydroxide. And if you do all of that math, multiply it all together, we end up getting 1.78 grams of iron 3 hydroxide. So what does that tell us? Look at our numbers. Remember, we're looking to see which of these two starting materials would have created the smallest product, the smallest amount of product. So in this case, 1.32 is smaller than 1.78, which means iron 3 chloride is my limiting reagent, and sodium hydroxide is my excess reagent, which means all of that math to find this one value here, which is my theoretical yield. So out of all of that work, the only value that I'm worried about and what I need is this 1.32. But if you do not show your work and demonstrate that this is my theoretical yield and not this one, then you haven't figured out all the pieces of the problem, and you have a 50-50 chance of being wrong. You do have a 50-50 chance of being right, but you also have a 50% chance of being wrong. So now that we have our theoretical yield, we know our experimental yield, because that's how much we created, our 1.10 grams of our iron 3 hydroxide. Now we can calculate our percent yield. So we just learned that our theoretical yield is 1.32 grams of iron 3 hydroxide, and we're comparing it to our experimental yield, which was given in our problem. Now remember, you got to make sure your grams are the same, your units are the same before you put them in this percent yield equation. So our final equation is percent yield equals my experimental yield, 1.10 grams, over my theoretical yield, 1.32 grams, times 100 with units of percent. Taking into account for sig figs then, our final answer is 83.3% yield. And that is our final answer for this type of problem. So it's a problem that asks us basically to determine the limiting reagent, but it does not explicitly say that. You have to be able to recognize that in order to calculate the theoretical yield, you have to conceptually figure out which one is your limiting reagent, and that's going to tell you what is your theoretical yield, which you will use to solve for percent yield.